I think he's going to give us a great talk on YANG and NETCONF, which I kind of pushed for because, for me anyways, I've always felt that networking was kind of a little bit of a proprietary bubble outside of all the infrastructure automation. So hopefully he can bridge this gap and tell us how the future is going to look. Please, a large round of applause for Pieter.
Let me just turn it up. All right, so welcome everybody. Thank you for attending the talk. So first off, some content warnings. So there will be no YAML in this talk. If you need your fix, I'm terribly sorry. I will mention XML and some related technologies. So if you are one of these people that really hate it, I'm so sorry. There will be ASCII diagrams. Yes.
Can you put the mic
a little bit closer? Yeah, sure. Is this better? Let me just. Right.
You talk. I'll make.
All right. I'll just keep talking. There is a mention of DNS as well. Not that many, and I will have some bad memes as well for you. So the agenda. Firstly, I'm going to give some introduction, both on. Sorry. That's fine.
How's that?
I can almost pick my nose with it. That's fine.
I won't.
All right, perfect. So I'm going to give you a small introduction on both me, how I got here, and what I'm going to actually, what I did the last couple of months. Then I'll just talk about the solution, which means I'm going to talk about NETCONF and YANG, what they are, how they work together, and how you can integrate it, and then how does this work in a more of a Unix-style environment, because this is networking technology, and as we know, the networking boxes are 100% different from all the machines that you and I touch daily. And then I'm going to do a wrap-up. If you have any questions, just interrupt me, or just do it at the end, whichever you like. So I have to, introduction. So who am I? I am Pieter, and I work for a company called PowerDNS. So I work for a company called PowerDNS. You might have known them. We make a very nice open source name server. My title is Senior PowerDNS Engineer, which means I have no clue. I just write some C++ and some Ansible in my life, and people are happy with it. Notice the lack of network engineer here. I have never done any networking except for like DNS, which people accuse me of being good at. And I've been doing CI/CD in my life. So how did I get here? A couple of months ago, the research department of one of our customers came to us and said, okay, listen, can you please Yangify the PowerDNS authoritative server? And we're like, what the hell? What does this mean? What are you talking about? And we're like, well, you just create a model, and you create this model for the server config, and the data that's in there, and then magic happens, because then we can just see this as a network function. And I'm like, what? What does this all mean? So then he said, okay, listen, hear me out. This thing's falling down. Just have to bend over each further. Yeah, perfect. So he said, hear me out. We have a fully defined nationwide network that is 100% software defined. It goes so far as they even use this NETCONF protocol that I'm going to describe a bit later on to provision and configure the modems at the customer premises. So there is no TR69 going on, there is no other protocol going on in the network to configure, there's only one thing. For them, the network is just a big machine that has one entry point, which is the NETCONF protocol. And all of the devices are known as elements for some reason. So a switch is an element, a router is an element, and within this concept, there also exists the concept of functions. So there is a network function. For instance, DNS would be a network function. Routing would be a network function. Having a MPLS network or an MPLS route setup would be a function of the network. And most of the ISPs and telcos are moving towards this kind of a model, simply because the 5G standard requires you to do all kinds of what they call network function virtualization, which is even a European standard. So the issue currently with most of the networking devices that exist is the CLI is different. Has any of you ever done things on a Cisco and then had to switch to a Juniper or some other device and were crying over your keyboards because you forgot how this device works? That is a problem. The other one is if you want to script this or do some automation on this, you're going to need to use expect, and different CLI versions might have different outputs. So if you get a new device that might have just a newer OS, everything's gonna suck. Also, there are of course different configuration APIs that many of the vendors have. And if you have a heterogeneous environment, it's just going to be painful. You cannot switch out a Cisco switch for Arista or whatever. Then there's Snmp. Who here is old enough to still know what that is? Wow. Okay, now I feel not so old anymore. Who here has actually written an MIB file in their lives? How was it?
Painful.
Perfect. Okay. So one of the other problems with Snmp is, first of all, it's unreliable. It uses UDP. Secondly, there is no real state. So, for instance, I have a counter that just tells me the amount of packets that passed a port. You can retrieve them using Snmp walk, but there is no real easy way to connect this to the configuration of that port. So, at some point, the IETF, or at least the network operators, got tired of this. And they published RFC 3535, which just is called operator requirements. This was in the time that the IETF was actually making documents to tell you what actually is going on. So section 3 is just a 12 requirements, which boil down to just we need automation and it has to be standardized. So in short, heterogeneous environments are painful. You need some standard configuration, API, or however you want to call it. And we need configuration and data in the same way. And these networking people, they're not different from us. I get this from a book on network management, and it says the CLI is no longer the norm. If a feature cannot be automated, it does not exist. And I believe this comes very close to the way of thinking especially this room in the config management conference. We want to automate things, and if it's not automatable, it's undeployable. So the solution, of course, is a ton of documents, because this is the IETF. This is what we do. And they've published a lot of documents. As you can see, they're about the first one is about 13 years old. And it consists of two parts. The first part is the actual communications protocol to do network configuration of devices, which is known as NetConf and RESTconf. NetConf, I'll get to that, and RESTconf is some REST API-like thing. YANG then is the modeling language to actually describe a device or the function of a device. This is a tree structure that I'll get into later as well, where one would just model the whole device and say, okay, this part of the tree represents this switch port, and these are all the functions that the switch port has, and these are all the counters that it might have. YANG actually means yet another next generation, so now you know what it means. So, how does NetConf work? It is a 4-layer protocol. If you disregard everything that's underneath the communications layer, and it mandates secure transport. So I think the only mandatory one to implement is SSH. So if you have a network device, it must talk SSH to do NetConf. Then it has some message passing, which is all XML. And on top of that, there are some operations. The operations are very few, so there are a bunch of them. You have lock, unlock, so you can lock the configuration or the data store that you're working on, or unlock it. You can do some transactions, and there's a retrieve information, a set information call, or set data call, and that's about it. When you look at a more bigger picture of the whole stack, so you have the YANG, that's actually the modeling language. Once you have described a device, it becomes what they call a model. This model, because it's just a tree structure, you can represent it in any way, shape, or form you'd like. Specified as XML, there's a JSON way of doing it, which also means you can probably do it in YAML, but nobody's doing it, and I guess we all know why. Then the transport mechanism is usually the NETCONF protocol, which I showed you is the XML-based messaging. Then there's also RESTconf that takes the model and then models the URL API on top of that. So that is also standardized how you translate the tree structure to a URL endpoint and the messages as well. There's also some gRPC and protobuf going on, although those are not that heavily used as far as I could see. Then you need, of course, some orchestration. There is the NSO, which is a Cisco proprietary orchestrator, although you can download it for free and play around with it. There's the YANG development kit, also from Cisco. There's Open Daylight, which is an open orchestrator for this. And there is also the ONAP project from the Linux Foundation, which is a full stack of tools to control and configure a whole network that also can do Kubernetes and all kinds of weird things, where NetConf is just a small communication bit in there. So when talking about NetConf, what features does the protocol actually have? So on the one hand, you get CRUD operations for all your configuration. The configuration is fully declarative. You have a device, it has a model, you know this device has this model, so your orchestrator can tell the device, hey, please, for these leaves in your nodes, set this configuration, and the device will say, yeah, sure, I know how to go from the state I'm currently in to the state that you asked me to go to. So the state will always be on the device, not in your orchestrator. Your orchestrator just has the view of how the system should be, and it pushes it out, and the devices will converge to this by themselves. The configuration and operational state is defined within this model, and it's quite human readable because you can get XML or JSON out, and even the models are very, very readable. There is a possibility to do network-wide transactions with full ACID properties, which is very neat. I can have a network of 50 different routers, and I want to have a couple of new routes between them. I can start a network-wide transaction from the orchestrator, tell all the devices, okay, here's your new configuration, and I do it a two-phase commit. Please apply this. If the configuration is bad, then the device will say, I'm sorry, I cannot apply this configuration for you. If that's all good, they will tell you, yes, I have committed this, but if I don't hear from you in 10 minutes, I will roll back to the previous configuration, because you might have misconfigured me and I'm now unreachable. So you can do full transactions over your whole network to, for instance, deploy a MPLS VPN from one end to the other. And if one of the nodes in the middle fails, it will roll back the whole transaction. So there is no half state in your whole network. Additionally, because this is all modeled and the devices internally also have this tree structure, it is very easy to go from state A to state B simply because they just apply a diff on the tree, knows what changed, and take the appropriate actions. So who uses and/or implements all this? There is, of course, most of the big vendors. And by the big vendors, I mean Cisco uses it, Brocade uses it, Juniper uses it, HP, Alcatel-Lucent, Arista, Dell. Everybody has implemented this. I don't think there is any other standard that most vendors agree on that they should implement. So this is quite something. And I believe that Cisco, even if you log onto the CLI is just a wrapper around the YANG data store that they have internally. So it's not even, you're not even having something separate. It is the same thing. You just talk to it differently at that point. Like I said, there are a bunch of orchestration frameworks. There's ONAP. That is from the Linux Foundation. It is a very big suite of tools. And also the ETSI, so the European Technical Standards Institute, I believe that's the acronym, or it might be French, I don't know, because it's European. They actually have the NFV, so the Network Function Virtualization Standards, that require you to have NetConf. So if you have customers in the telco world and they're moving to 5G, you're probably going to have to either read the NFV standard or just say, yes, I know what I'm talking about. Also, it is a huge standard. And there are several Unix applications that support this, and there are some libraries as well, and I'll get into that later. So, how do I model data? So YANG, like I said, yet another next generation, because they tried, I think, 3 times before to specify some next generation protocol for configuration, and at some point they just ran out of names. So the schema defines the data. Think of it as a DTD for XML, but not as shitty. I mean, DTDs are just very ugly. So the NetConf server, by server then I mean a device that has NetConf. It has a instantiation of this data tree, and this tree lives in memory or on disk. You have the concept of different data stores that I'll get into, but as you might know if you've ever touched a router, for instance, there is a copy run startup, whereas if you would pull the power, it would start up from the startup config, which can be different from the currently running configuration. The schema, like I said, it is a tree, and the cool thing about trees is you can make references within the tree to other parts of the tree, and the whole model and implementation ensures that if you make a reference to another part of the tree, it must exist on the other side as well. Otherwise, your configuration is rejected by the device. So how does this language look? And don't be scared. It is not as hard as one would expect. So I've been doing this for 2 months, 3-ish months, and I get most of it. And it's actually relatively easy to write these models. So here I create a grouping. A grouping is nothing more than a bunch of leaves, so end nodes of the tree combined. I call it endpoint. I give it a nice description, which means that if you ever read this, you know what it means. And this has an IP address, which is of type IP address without a zone marker or without a zone information, and it has a port. I then have a container, which is configuration, and it says it has a list of listen addresses. A list is as a dictionary in Python. It is keyed to a certain name, and it has an n amount of end leaves in there. The name is a string, and however, also the IP address and port must be unique within this list. So if I create a list where I have 2 IP addresses and ports that are the same, give it a different name, it will still be rejected by the device because it says no, these must be unique. And it uses the endpoint here as well. So I say, please take that grouping endpoint, which are these 2 nodes, and just put them in this container that is called listen addresses. However, I'm doing something special here. I'm saying, listen, it's nice that I have defined this IP endpoint. However, for this specific device, the endpoint is usually an SMTP server, for instance. So I refine the port leaf to have a default value of 25. If you then try to send me some configuration without the port leaf in there, that's fine. I'll just say it's port 25. And if the configuration then changes, I can do things with it. The bottom one, the container there, has the config false in there, which means this gives you some state. If you would inquire about the state of the device, this would probably be a counter on how many connections were on the server or whatever. I didn't put a description in it because this is just an example anyway. There are some tools to actually express this tree for you. So this is made by Pyang. And it's very simple. It just tells you I have a module, which is called my example module. It has a read-write container, which is called listen addresses. It then has a list in there, which is called listen address. The star indicates that it has 0 or more. One of the other constraints you can do in YANG is, for instance, say, okay, I have this list, and I need a minimal of n elements or a maximum of y elements. It tells me the port is optional, but the IP address is mandatory. And then there is a read-only counters container with a connection count in it, which is typed as a uint. So these things that I just talked about, here are some definitions. So the grouping, it's a set of nodes that you can reuse. So the IP endpoint, if I have a very big model which has multiple listen ports, or if I have a DNS server that needs a master but also something that can be notified, I could use the same grouping just within a different part of the tree. Container, just a set of related nodes, just to make things easy on yourself. You have the list, which is a keyed set of nodes, so it's like a hash map where the keys must be unique, and you can put some extra constraints in there. And then you have a leaf list, which is just a list of single items. So I could have a leaf list of IP addresses if I want, for whatever reason I need. Then there are a bunch of like built-in types. After that, you can actually redefine or revise some of these types. You have all the things you expect: integers, decimals, strings, bits, booleans, enumeration, and unions. Unions can be used, for instance, if I have a end node that describes a remote endpoint. I can say, well, it's either a string or even better, if I have a type defined for URL, it's a URL, or it's going to be an IP address. There's some other tools within the language. So there's the import statement. Many of the standard organizations have created default modules. As you saw earlier, there's the inet IP address that I used. That is actually a module made by the IETF. They have taken all the IANA registries and all kinds of handy things that exist within the networking world and made ready-to-go modules for them. Which means that any vendor can just pull them in. So if I want to use an IP address no zone on a Cisco device, I can, because Cisco implements the same thing as Juniper does. There are also standards that you can import, like there's an SSH common, an SSH client, and an SSH server module from the IETF as well. This will allow you to model a SSH server. But because you have this, you also need suddenly certificates, so there's also X509 stuff. There are a lot of ready-to-go modules. You can use augment. Augment is a way of, once you have imported a module that, for instance, defines a network interface, but however your device that you're building does not support providing counters to you, you can say, okay, I have this interface, it has a name, it uses this basic module, however I augment this part of this path within the tree to not exist, because I don't implement this specific part of the module. There's grouping, like I said, a set of nodes, containers, and there's a feature flag. This is very neat. You can have within the model a couple of features defined. For instance, a device can have the feature, I support a DHCP server. If you do not turn this on, parts of the tree are just not possible to see or set, because they are marked as only enabled when the feature is enabled. So the tree is always the most minimal set of, is always as small as it can be. So when you look at these upstream modules, so the port number that the IETF has, it's just a UN16, which is of course the proper size, and it has this range. That's nice. So if you ever have written a regular expression for an IP address, this is how you should do it, according to the IETF. But now you never ever have to do it, because you can just reuse their module. Underneath, you see that they have defined also a IPv4 address no zone. So that means there is no % with an interface name behind it. And the pattern is way simpler. That is because if you make derived types and put in more constraints, the constraints are ended together. So if you have so here you have the first one is a proper regular expression for a real IP address. The second one just says, yeah, we don't need all that cruft in the back, so this regular expression combined with the first one is fine. And you can keep deriving types. I could even say, well, I'm going to take the IPv4 address no zone and going to derive my own type, which is an IP address with a 0 at the end always. You can do that if you want. Then, like I said, we have unions that you can combine things. So because we have two IP versions on the internet, although many of the cool cloudy stuffs don't agree with that. They just have IPv4 and that's it. There are actually two. So you can create a union type that is either an IPv4 or an IPv6 address at that point. So this is the model I showed you. So I'm just using the IP address no zone, and I know because of this it's going to be an IPv4 or an IPv6 address. If you try to insert any other data, the orchestrator is going to say no. If the orchestrator is badly written, it will try to push out this configuration information to the device, and the device will say, "Nah, that's not the right format for this thing." This is also what I said before. I'm using an endpoint. I refine the port. It's going to be default 25. If I would make a model and would say for the port the default is going to be foobar, I cannot even load this into my application because it says, sorry, this just is impossible based on the previous definition of port. And the same for the counter. So it's just a type and it's fine. So the reuse of models. You can keep importing modules. So if there is a vendor that has something special, you can just import it and reuse it. Like I said, modules are published. ITF, Etsy, there's the Open Daylight project. They do very cool open source YANG modules that have, well, they're not basic, but they have all the building blocks that you need to ever describe a device. There's the IEEE, known for the Ethernet standard, of course, and there's the Broadband Forum, which is some telco organization that does, I think, DSL and all kinds of other weird things. There's a large collection of building blocks, TLS server, client, already discussed that. And many of the, let's say, downstream vendors use these modules to describe their devices. So you get a lot of bang for your buck if you have good groundwork. You can just take a different device, and with minimal changes, you will probably have the same configuration on there within a few minutes. And there is a GitHub project that collects all these, which is quite nice to look through. So if you're looking into a tree structure, there's always the point of addressing. The IETF, in all its wisdom, chose to do XPath because it's pretty good expression language. It's, I think, from the W3C actually. And it can do all kinds of weird things. You can do things by name. You can say, okay, give me the latest element of this list. You can even give me all the interfaces that have a Y in their name. I don't know why you would want to retrieve this information, but you could. So if you are running a big network, it is very simple to retrieve the most minimum set of data that you might need for whatever operations you're performing. So how do you create, or how are these servers built in the end? So a NetConf server is just a device that exposes port 830 TCP, where you can connect via SSH and then talk NetConf over that connection. So the client app can be anything. It can be your laptop using a NetConf client. It can be the orchestrator. It doesn't really matter. It just talks to the NetConf engine to do all the RPCing. And then there are the models that have been loaded into the device that you see at the top. The server has a bunch of metadata. It has also its configuration database. It has its state data. It can do notifications. I'm not going to get into that real deep, but if you can configure a device to send notifications over NetConf. So you can tell it, okay, here is my NetConf client or my orchestrator. If some counter reaches some certain threshold, please send me an RPC message so I can get alerting. So there is some pull or some pushing going on if you want. Although that's a very relatively recent specification. Before you had to pull data from the devices. And then there are software components that can be anything that is just running on the device. So if you now look at this describes any kind of computer. It has some input, has some output. You just need the right format. This is what I've been playing around with. So there are a bunch of data stores that are defined. There is the startup data store, so that is once your device boots up, this is the configuration that it gets. Usually one would copy the running configuration to the startup configuration every time you make a change, but you don't have to. There's the running configuration. This is a data store that tells you the exact configuration the device has at this moment. That is, I think, the only mandatory one that one should implement. The other ones are all not mandatory. When the device boots, startup is copied to the running config. And there is a certain candidate data store as well. The candidate data store can be used to do multiple changes in multiple different NetConf transactions. And once you have a candidate data store, you think, okay, this is going to have to be the final configuration of the device. You can say commit, so you send a commit message to the device, and it will copy that to the running configuration. And if you do this two-phase commit thing, it will do it. And if it doesn't hear from you within 10 minutes saying yes, confirm, then it will go back to its previous configuration. And then the last one, that is the operational data store. It's kind of a virtual data store because it's kind of a view on the whole device. So it's a layer in front of your running data store that includes any other state data that might be on the device. So if you're, this is straight from the RFC, of course, as you can see by the nice font. The operational data store has configuration items, has non-configurable items, and is read-only, because that is the exact system state. And it just cobbles together the whole tree of everything that's on the device. Which is quite nice. So I would love to give some demos on this, but first of all, I don't like giving demos, and secondly, working with NetConf from a command line is quite hard, I think, although many of the frameworks I described make it very easy to do small changes. So how would this work on a Unix kind of system? And first of all, why should you care about this? Because this was my first reaction when this customer came to us, like, why would we care? We're a software company. We deliver a Debian package or an RPM with some software, and here's the configuration information. Have fun. So, according to many telcos, which is our biggest line of customers, many of the applications that actually run on the Unix system can be considered a network function. So a DNS authoritative server would be a network function. A mail server could be a network function. So they would like to have this configured in the same way they are used to configure their whole network anyway. So with the right orchestration, you can even have a versioned infra, because the orchestrator keeps, of course, a log of everything that it did, and because it can just know the whole state, or at least the whole configuration in a tree structure, it only has to save the diffs. So if you want to go the other way around, it can easily generate a new message saying, okay, please, this is going to be a new configuration, and it's going to be a rollback of the previous one. Also, configuration management in telcos is not very common. Many of the departments, so from what I've seen, many of them are split. Either in we've outsourced everybody, so let's not talk about that. But there's going to be a Unix department and there's going to be a networking department, even though they have to work together and are basically in each other's, fishing in each other's pond at that point. In the Unix department, you see Ansible, you see Puppet, you see Chef, all these things. But the networking people don't want this, because that is not how their devices can ever work, because they're not really general purpose computing devices. And even without NetConf, when you think about it, YANG is actually a very powerful language, or a very powerful way to do the configuration of a single piece of software, because you can very strictly define how this configuration should be. You can have a configuration option that is of a unit that you call %, which means it's an integer between 0 and 100. And if somebody tries to configure anything else, it's just going to error. I have looked around a bit. I think there's like JSON schema that allows you to do this. There is a DAL language that is for Haskell. It's actually very neat. DAL actually also allows you to do some scripting inside the configuration definition language. But then you have to run Haskell and everything. And having just typed and constrained things in your configuration just makes a lot of sense, in my opinion. And of course, it integrates into telco environments. So if you have a customer that is a telco, you might get asked about this at some point. So what kind of software exists? So this is all open source. So there's libyang, which is made by the guys from Snmp, I think. Although many of these tools, like the first three, are I think written by the same guy, because every time I file a bug against one of them, the same guy responds. And so libyang is a YANG parser and toolkit. It is very neat. It gives you a way of loading a YANG schema and then just create nodes or retrieve nodes that have been configured beforehand. You can give it a bunch of JSON and say, hey, this is the configuration, by the way, and it will tell you, oh, but in the model you defined this is not correct. You're trying to put a string where an integer should be. I've used this in one of my in the program that I'm going to talk about in the next slide. To model the PowerDNS configuration, and now it just errors out if you try to put a non-IP address in a field that needs an IP address, whereas the regular PowerDNS would just restart and then not start because I don't get it, but there is no check beforehand. There's also libyang has C++ bindings, which is nice for me. It also has Java, Python, and JavaScript language bindings. So if you would be interested, you can write a tool in any language and just have configuration modeled via YANG. Then there is sysrepo. This uses libyang as well, but this implements the actual data stores. So you can have on your Unix system a YANG data store, a running configuration, a startup configuration, and you can manipulate this. NetOpeer is a NetConf server that also talks to sysrepo. So if you have a NetConf server, if you have NetOpeer installed, it will talk to sysrepo, and if you have something that listens to that, that also just goes into the data store, you suddenly have a network device, according to many people in the networking world. There's the YDK from Cisco, which is a YANG development kit. This allows you, if you have a YANG schema, to create bindings in several languages for all the information that's in there. So it would just create a server stub for you that you can just have to fill for actually retrieving or for sending the right data. And then there is PyYang, which is a nice validator and transformer as well. So the thing I've been writing, it's called PDNS sysrepo because it's a sysrepo plugin. It uses libyang and sysrepo, and it can configure the PowerDNS authoritative server. Because PowerDNS doesn't actually use libyang or sysrepo by itself, mostly due to licensing issues, this is a separate tool that listens to sysrepo. Upon startup, it will actually pull down the configuration that is in the YANG data store and will write out a configuration file on disk, then ask systemd, please restart the service. And as we are templating all of this, we know that the configuration is going to be fine. We also know, because we have the model correctly, we know that every element that we're going to put in this configuration already has the right format. It can even store zone data in sysrepo. I was first very much against this because from my perspective as a DNS server writer, zone data is data. It is not part of the configuration of the device. But if you talk long enough to these networking people, they say, no. The data is also configuration for us because it is a function. So I just say, this device has a DNS function, and this is the configuration of the zones that it has. This is the data it needs to serve out. This was a source of a lot of confusion in the beginning. And for PowerDNS, those who know it, it exposes a remote backend. So it just has a small API that PowerDNS talks to actually retrieve this data from sysrepo. And it's actually quite fast because the whole YANG and sysrepo data store are in memory. So, wrapping up. In conclusion, the network world is not as different as we are, although they just work on a very, very different level. YANG and NETCONF are the industry standard, so there is no fighting between the different, well, fighting is maybe the wrong word, but there's no competition between the different configuration management methods. There is just one, or you're stuck with a CLI. I think it is a viable technology to use within your Unix applications to at least have nicely constrained configuration languages. And that's it. Thank you very much for having me. If you have any questions, I'll be here today, tomorrow, or you can do it now. Thank you.
Do you have some questions for our fabulous speaker? We have actually time. You're 5 minutes early.
Yeah, perfect.
So we have lots of time for questions. And if you don't ask 5 questions, we don't let you go on the break. So please.
or I can show you some demo if it's working. If you
want to see a demo?
All right. Let's see if I have to. Let me just close this one. All right.
And if David, Adam, or Matteo, the next 3 speakers, are here, please come up and see me. And if you know them, ask them to come see me. Please. Thank you.
Wait,
demo works. You get the chocolates. Otherwise, you.
Oh, okay. Let's see. All right, so let's hope it works. I'm just going to quickly copy my screen because otherwise it's going to be hell for me to actually know what I'm doing. All right, so let's go. All right, now I can actually see what I'm doing. All right, is it? Yeah. All right, good. So let's see. It has been a while. All right, let me just first look at the modules that I have installed. So I have, hopefully, everything ready. So, because I didn't expect to do a demo. That's not my password. Nope, that's not my password. There it is. All right, well, that's unfortunate. So, as you can see, I'm asking sysrepo, hey, can you tell me which modules I have installed? And I have a bunch of them installed. So I have a DNS zone common. I have some IANA things, I have a bunch of ITF things, and then I have the PDNS server one. And I have enabled a feature called RSet management. So if I have a look at the, let's see, yeah, there it is, good. So give me an export of the running data store. Let's back that through less, because otherwise it's going to probably be a lot. Oh, why are you, oh wait, I did the edit one. Hang on, give me a second. Minus E is edit. So this is my configuration at the moment. I have a master's endpoint, which just means this is a named endpoint for a master of a zone. I have some other configurations. So my service is called this, so it knows which service to restart. And please write the configuration file out to that. Because my tool, PDNS sysrepo, is configured with sysrepo. When I started out, it was a YAML configuration file, and then I realized, wait, I'm using a configuration data store for everything else. Why not for the tool itself? This is the server configuration itself. So I have a bunch of listen addresses, or actually I have one, and that one's called main. It listens on this IP address and this port. And I have slave turned on and master turned on. And I'm defining a bunch of zones. So to show you the power of this, so this is an IP address. This is not an IP address. And if I would want to store this, sysrepo tells me, nah, that is an invalid value that you're trying to put in there, and it just rejects all those changes at that point. Similarly, if I would have the port number on a very ridiculous number, it will also tell me, no, that's not valid. Also, so because I know the model, if I put a foo element here with the value false, and I try to store it, it will tell me, sorry, that's an unknown element. I don't know what to do with it because you have not defined any of this. Yep, so that's fine. So I have a zone. It's called master.example. It has a bunch of zone data in there. I'm going to show you that I can actually query this, hopefully. And it has SOA record, all kinds of stuff. And it has a slave zone as well. So it can actually slave zones and then store the data inside the YANG data store. At least hopefully, because I finished that feature 2 days ago in a bar while I was drunk. So let's just go to the build directory. Ninja.
Using Ninja.
Well, yeah, I used the Maison build system. Oh wait, I have installed a new boost. Let's see if it just works. Right, so I have to build a new version because I installed an update to Boost yesterday. I'm sorry about that. In the meantime, let's just have a look at. There we go. Let's see if I can actually get the operational data store as well.
This should have been the talk.
Oh, I'm sorry. Well, let me just show you the model. So there it is. So although I'm not a big, so I started writing this a couple of months ago while I was very green with it. I would have done some things differently now. But as you can see, I am importing a bunch of things. So I am importing the INET types, which I prefix with a certain name. This is a draft that is now out. This just says, okay, this number is this record. It's very easy. A bunch of revision data, backend information. So here's the endpoint that I've shown you before, and let's see. This is So this is how I define all the data. So if I have a SOA record, it has a bunch of other information. So it has a bunch of leaves. It's the M name, so the name server name. It has the serial, the refresh. Well, all the fields you would get are separate leaves because they have their own rules. Millions of containers for all those tools. So what does the zone look like? Well, it has a name, it has a class, it has a zone type, native, master, slave. It can have a leaf of masters, but only, you can see there, when the zone type equals slave. And it will actually reference the masters I've showed you in the configuration beforehand. And this element only exists when the type is slave, and if you put in 0 masters, it will also error out because you need a master if you have a slave zone. Well, a bunch of other configuration, state, there's a web server information, and this is the sysrepo itself. So you can see here, I have a string for the service, however it must be something .service in the end. And you could even do way better things than I did in the regular expression, but this is good enough. So let's see if we can, Right, let's see if it works. Okay, neat. I just need to start PowerDNS. So one of the things you notice here, because I'm running in debug mode, it actually tells you the configuration it generated from the data store. So I have no AXFR ACLs, I'm not notifying anybody else, and it's launching a backend that just listens, or that just goes to my tool itself, and the web server is disabled. And then a bunch of other information. So let's see, I have a different directory with all the config because I am like that. Conf, netconf. All right, and I'm pretty sure that PowerDNS now won't start because it also has to be rebuilt against the boost. Yeah. Yeah, that's going to take too long. So just believe me when I say that the information that is in the data store can be retrieved through DNS, which then goes through my tool and looks in the data store and just gives you the information. And you can just online change this. And just before this talk, I had confirmation by our customer, they're running this in a test environment, that this is actually integrated with their Cisco NSO right now. So the orchestrator knows about this, and they can now serve data straight from YANG. So yeah, I guess that is the time, right?
That's it. One more large round of applause for Pieter, please.